Hi all, my name is John Handler. I'm a solutions architect with AWS, and I cover search services and our Open Distro for Elasticsearch. We're going to talk about Open Distro for Elasticsearch today. We're going to give you a little bit of background, talk a little bit about Elasticsearch itself, and then talk about using our security plugin for Elasticsearch. So just quick poll of the room. Who is already using Open Distro for Elasticsearch? Maybe half. Okay, cool. And so you folks obviously know about Elasticsearch, but we'll go ahead and talk a little bit about Elasticsearch more in general, just to give other folks some background. So who has any software that they run? Yeah, I know, right? Everybody, right? So, and that software undoubtedly puts out log information, right? And your logs are actually a key source of the information that you need to understand what your application's doing, issues that you're running into, if you're a DevOps shop, the performance of what's going on, and to dig in and be able to make it run right. So you've got logs, but what's the problem with logs, right? Logs are a big wall of text. And in fact, if you're running any kind of application at scale, you've got 10,000 servers out there somewhere, and each of them has like tons of log data in it, and somehow an error is buried in there somewhere, and you've got to go find it. So Elasticsearch is a tool that allows you to collect all of this log information from out in outer space, bring it into one location. It's a search engine. It provides you the capability of going into the logs, searching across everything, finding your errors, finding all of that. As well, Elasticsearch provides capabilities for analyzing the data in your logs so that you can build graphical representations of what's going on, like your aggregate CPU usage, or your aggregate host count, or the number of 503 errors that you're throwing. And Elasticsearch, started life as a search engine, but really came to the fore with this log monitoring use case because it's tremendously useful for it. So the kind of stuff that you find in your log data, you have perhaps application usage data, right? So if your front end is instrumented, it's sending out information about which pages your users, your customers are visiting. It's sending information like in an e-commerce setting about what customers are clicking or putting in their cart or purchasing. So you have all of this application usage and clickstream data that's tremendously useful. You have faults, errors, security information. Again, as I mentioned, if you're throwing tons of 503s, you're going to see that in your logs. If you have fraudulent usage or failed login attempts or denial of service, all of that's going to show up in your logs. You also have your uptime, your resources, to make sure that your application is functioning within the specs that you want it to function in. So Elasticsearch, again, as I said, started life as a search engine. It came to the fore with this log analytics use case. And you can see here, this is DB Engines. Elasticsearch actually technically a database. We'll get into that a little bit. So with Elasticsearch, you send your data in a structured format, and you're going to run queries against that. So it lives in the database universe, although it's not a relational database, obviously. Very popular software right now, driven a lot by this log use case. In the open source world, we have Elasticsearch Logstash in Kibana, called the ELK stack. Elasticsearch provides you with the core search and analytics capabilities. Logstash provides you an ingest tool that can do changes to the streaming data that formats it in the way that Elasticsearch needs it. And Kibana is a thin web client that connects to Elasticsearch to provide you the ability to do visualizations. So what is Open Distro for Elasticsearch? Yay. Open Distro for Elasticsearch is an Apache 2.0 licensed distribution of the open source version of Elasticsearch. And the open source version of Elasticsearch is already available as open source software. With Open Distro for Elasticsearch, what we've done is we've actually developed and built additional plugins on top of Elasticsearch to provide additional capabilities in terms of security and alerting, SQL, deep performance analysis. We'll get into all of that. And we've open sourced those as well. So Open Distro for Elasticsearch is not an AWS service. It is open source software that you can deploy and run yourself to provide Elasticsearch along with these additional plugins. And really, when we're thinking about it and why Open Distro for Elasticsearch, there are several sort of tenets that we went with that we wanted to really hit. First of those, 100% open source. We have some confusion around Elastic's open sourced version of Elasticsearch. Some of the licensing is a little bit unclear. It's a little bit hard to tell which portions of the software you can deploy, what you can change, what you cannot change, et cetera. So we wanted to provide a distribution of Elasticsearch that was fully open source, that you can rely on that Apache 2.0 licensing to do what you need to do with it. Again, we wanted to add additional features and functions that we felt the Elasticsearch really needs at an enterprise level. So for security especially, we provide deep security module. We'll go into that in a bit. Also alerting as your data is going through. It's tremendously useful if your logs are showing tons of 503s, you want to send out an alert about that data. Or if you have tons of failed login attempts, you want to send out an alert. SQL interface, we also provide. That's really for shops where you're already used to using a SQL interface, and so having that SQL interface helps you adopt it. And then the cluster diagnostics is deep level instrumentation that we did on top of Elasticsearch to provide you really good information about how to scale your cluster and where the bottlenecks are, choke points, all of that. It is community driven, so it is not, again, an AWS service or an AWS product. We do look to our community to contribute, to send us issues, to send us code, what have you. We really want to make this a true open source effort. I think we've mostly gone into detail about these, but with security, we're gonna see how you can achieve fine-grained access control for different sets of users within Open Distro for Elasticsearch. So if you have log data coming in from different groups in your organization, you can make sure that Group A cannot see Group B's data, and that Group B can't see Group A's data. You can obscure what's coming out. You can do all kinds of stuff to keep your data secure. For alerting, again, tremendously useful to be able to alert on the data in your logs and to be able to respond to issues and events that are happening as they're happening in real time. SQL, again, interface provides shops that are used to SQL with the ability to run SQL. We have a pretty rich set of SQL language that we've implemented. Elasticsearch, again, not a relational database. So while we did implement one join, it's not particularly performant, and you should not expect to use Elasticsearch to do anything relational like joins. Performance Analyzer, again, deep instrumentation provides you the ability to scale your cluster. All right, so let's just do some quick Elasticsearch basics. So Elasticsearch is a database, and it works like a database. You have some sources of data, which are your server, your application, your network, your AWS, all of these other servers or applications generating log data, and that is going to your Elasticsearch cluster. The other use case that we see for Elasticsearch is a search use case. So perhaps you have an e-commerce catalog, and you want to provide search across the items in your catalog. Elasticsearch is a search engine. It does provide you the ability to query, to build relevance, to build complex functions, to bring back the right data for your customers or what have you. You send that data in JSON to Elasticsearch. When you use Elasticsearch, it's got a REST API that you send a REST call to send your data in. Elasticsearch then indexes all of the JSON that you send to it. Every field that you send in has an index associated with it, making that field queryable. Right. And then on the other end, your developers, if you're DevOps, your application, if it's a search application, your IT folks, all of those folks are going to send queries to Elasticsearch and get query responses or analysis out of Elasticsearch, right? So that's overall how you interact with Elasticsearch. Now again, you use REST APIs to send data to Elasticsearch. So you use a post, you have an endpoint, that's the location of the REST endpoint, and then you send in to a particular index the documents that you want to, the single document in this case that you want to index. And that's just JSON with field and value. You also have a bulk API, right? So you can send single documents, but for best performance, we always recommend that you use the bulk API. The bulk API allows you to intersperse actions like index or delete or update along with documents to apply those actions to. Asterisk, generally your ingestion tool is going to figure out and do this bulk request for you, but I wanted to show you this is the simplicity of using Elasticsearch. Just send data as JSON. Use query APIs to retrieve data from Elasticsearch. So in this case, we're issuing a GET to the search API against the logs index. And here we're querying for the verb is GET. This query will retrieve from Elasticsearch if it's Apache weblog lines, which is the source of the data, it will retrieve all of the Apache weblog lines as JSON that have GET as the HTTP verb for them. That goes into our query engine. There's not really a query engine in Elasticsearch, but you can think of it as a query engine that's going to go look at the verb field and go find matches for the query term GET. It's going to generate those matches, and that's going to be some set of documents. It then applies a scoring and sorting algorithm because Elasticsearch is a search engine. So like if this were e-commerce data, you'd want that ranked according to relevance. It applies that scoring and sorting algorithm, returns you the ranked results. In the log use case, you use aggregations to analyze data. Elasticsearch aggregations come after the match set. So in this case, we have a query. We're going to select out the set of records where the verb is GET. That's going to be the same query engine and matching that we already did. Then we're going to go and run the analysis engine. Again, there's not actually an analysis engine, but you can think of it as the analysis engine. We're going to run that over the source data for all of those records to build various charts and graphs. So you can think about, I go in the GET, and then I want a histogram of the IP addresses that were the sources for those GET requests. So I go look at every GET request, I pull out the IP address, and I build that histogram that way. We're going to do numerics. So if I have something like the CPU and I want to compute an average CPU, I issue my query, I get my matches, and then I go vertically and I figure out my CPU. We have terms, so we can bucket by terms. We have nesting, so you can nest your aggregations. In a sales case, you might want to say top sales by region, by city, and by sales associate, or what have you. With Kibana, then, which uses exactly this interface, you're able to build visual representations of the query results to see what's going on. This particular thing we have is performance analyzer output, actually. So you can see I have graphs with things like CPU utilization, I/O wait times, various other things. That is Elasticsearch. So let's transition to Open Distro for Elasticsearch, the security plugin. Sorry, my clicker's being weird. So with Open Distro for Elasticsearch Security, we wanted to provide you the means of securing the data in your Elasticsearch cluster and providing access control at a document, field, and index level for your users. The security plugin provides you encryption. So it works with SSL certificates, and you can encrypt data to your endpoint. You can encrypt data within your cluster. We have authentication, various means. There's basic authentication with user password. There's integration with LDAP. There's integration with other federated providers. There's all kinds of ways that you can provide authentication. Authorization, again, granular access control, which user can do what. And audit logging. So when you see security problems, those are actually logged to that Elasticsearch domain or Elasticsearch cluster, and you're able to see audit logs of what's going on. So we're going to sort of embark on an extended demo. But before we do that, let's talk about some of the security concepts that we're going to touch on. First of those is users. So within the security plugin, you define users who are authenticated entities. Either you're going to import those users from your federated provider, or you're going to create them manually within your Open Distro cluster. User has credentials. There are back-end roles that map onto your federated providers. Users also have a role, or multiple roles. Roles collect actions that that role is allowed to perform. So we assign roles, we actually assign users to roles to give them permissions. Permissions are things like read indexes, make cluster changes, all kinds of different things, admin, etc. Now the permissions themselves are actually grouped into action groups. An action group, collection of permissions. The action group is what you actually set within the role. The action group provides you the authorization. Backend roles, again, those are the roles that come from other providers, other authentication providers. And you use role mappings to map particular roles to particular users. Okay? As I mentioned, you can provide encryption as well. So you have TLS that you can provide to your endpoint, and then you can have TLS node to node. This is our first picture, actually, of a cluster. Within an Elasticsearch cluster, you have a set of nodes. So Elasticsearch is a distributed database algorithm. You have client nodes that provide you the ability to receive queries and distribute them across your data nodes. Your data nodes hold your data and provide query and indexing across that data. And then you have master nodes that actually orchestrate the cluster. Something akin to Zookeeper, although they're not Zookeeper. So you can have TLS within the cluster itself. All of these nodes are communicating with one another, and then TLS to the endpoint. So when a request comes in, how does Open Distro for Elasticsearch Security authenticate it? Well, the request comes in with some credentials. Open Distro Security checks with any backends you have set up and backend providers to see whether that authenticates against that. If it does not, then it goes to the internal database that it has of users and tries to authenticate it there. And then based on the authentication, it pulls out roles that authenticated entity is allowed to, or has, and that gives it the permissions to do what the request is saying. Either they can or they can't. So the user provides the credentials. Plugin authenticates the credentials against the authentication configuration. Again, in multiples if that's relevant. And then collects the roles that are mapped to the user that allows that user to do things. Okay, so let's talk about our demo. What we're going to do is we're going to run Open Distro for Elasticsearch. We're going to add 3 indexes. In Kibana, you'll see we have 3 different data sets. One of them is e-commerce data, one of them is logs data, and one of them is flights data. So we'll load all those in. Then we're going to have 2 users. Now, you can think of this as not single users, but this could be, Group A and Group B in your organization that you want to have them accessing these things. So let's get that set up. All right, first thing I'm going to do, and by the way, so Open Distro for Elasticsearch has Debian, RPM, and Docker distributions. I'm going to run it here on my laptop with Docker Desktop. It's really easy to get started, easy to make it work. I have a blog post out there that walks you through this. Also, it's in our documentation. So we'll get that started up. right. So once we do that, oops, come back. So we can connect Kibana at localhost 5601. Not yet, though. No, it's good. Like, this thing has been flaking out on me all day. Let's try one more time. By the way, this is running a 2-node cluster with Kibana as well. Okay. That looks better. All right, let's try this again. Okay. So, looks better for me, but not for you guys. Oh, I can't do this. Let me try and mirror it. Sorry, gang. Just 1 second. Okay. All right, that's better. Okay. So what we've done is we have an Open Distro for Elasticsearch cluster running on my laptop. Kibana is there. Kibana is, again, thin web client. It's going to provide us access. So first thing we need to do is log into Kibana. And our goal right now, by the way, is to create 2 users for Elasticsearch. So I'm going to log in as the admin user. The admin user gets to do everything. Of course, it's the administrator. So let's explore on my own. And while we're here, so I'm not sure exactly how much to show right now. So right now, these are the different applications within Kibana that you interact with. We have a Discover panel that lets you see some information about what's going on in your logs. We have visualizations, dashboards. This is our alerting plugin. We have a dev tools here. Why don't we look at this? Nope, nothing going to be there. And then index or settings. And then here's our security plugin right here. Okay, so as we said, there are a number of different sort of concepts or areas that we go here. We have our role mappings that map roles to users. We have our roles where we define the permissions that those roles are able to have. We have action groups that collect permission sets that allow us to apply those in roles. And we have Kibana tenants, which we're going to talk about later. We have our internal user database, and as well, we have some authentication and authorization for adding in additional backends. So in this case, we're just going to create 2 users. We already, by the way, come with some users. We come with an admin user who can do everything, Kibana read-only, Kibana server, logstash read-all. All of these are predefined roles that allow Open Distro to work with various open source tools. All right, so to create a user, it's pretty easy. I'm going to give a username. We're going to call it ecom user. And I'm going to give it a really hard password so that nobody can hit my laptop. OK. So we now added ecom user to our database. We're also going to add a flights user. And the reason I'm calling these things will become clear in a second. And let's give it a password. OK. So now we have an ecom user and a flights user. They are defined. They can log in, but they don't have any permissions yet, right? So we can do, if we do a log out, I can log in as my ecom user, and I can give my password. I can log in. But if I try to do anything here, I'm going to see a lot of nothing, because I have no permissions yet. I've simply created the user. Okay. All right. So let's go back out of. So we now have this scenario. So we see we can log in and create users. So we have essentially we have role-based access control that we are now going to go set up. So this is going to control things like which users can access which indexes, which documents they have access to, which fields of those documents they have access to. Are fields anonymized before they're sent out to those users? And multi-tenancy we're going to do in a minute. When we get done with this, what we're going to have is we're going to have our ecom user and our flights user. We're going to have an ecom role that defines permissions and index access for the ecom user. We're going to have a flights role that provides access for the flights user. And we're going to have a logs role. Again, we have 3 indexes: e-commerce, logs, and flights. Flights gets access to the flights index, and the logs role gets access to the sample logs, and the ecom user gets access to the ecom data. Both of the users are going to have access to the logs role. Okay? So ecom for e-commerce data, flights for flights data, and then everybody gets access to the logs. And if you think about it, what I'm trying to illustrate here is that you're going to have some tenants and some data that is specific to particular groups. You're going to have some data that is shared and common. And so you want to provide access in those different ways. So what we need to do then is create roles, these 3 roles: ecom, logs, and flights. So let's do that. All right. We're going to come back to our security plugin. All right, and we're going to come to our roles tab. And I'm going to create a new role. And I'm going to call it the ecom role. So this is going to be access to the ecom index. How do I do that? So by the way, I have cluster level permissions that I can apply for this role, as well as index level permissions. For this demo, I don't actually need any cluster permissions. We're just going to stick with index. So let us add index permissions. Now, I have the flexibility here to define a wildcarded index pattern. So this role can give me access to one specific index or to a set of indices based on a wildcard here. In this case, I know it's Kibana sample data e-commerce. So that's my index pattern. That's the indexes that this role has access to. And then the permissions action group tells what permissions that role has over that index. Okay, so I'm going to add indices all, meaning that this role can do anything it wants to this set of indexes. Okay. Now you'll see I also have document level. I can specify with it which documents, based on a query, this role can access. So if I have multiple data sources even within an index, say some of them have financial or private data, and I don't want this role to access that data, I can filter out all of those documents based on a query. I can include or exclude particular fields within that data set. Again, those documents are JSON. They have field value pairs. I can pick fields that this role does not have access to, or does have access to, and I can anonymize fields. For this demo, it's going to be fairly straightforward. We're just going to create that role with the Kibana sample data. All right, now I'm going to quickly do that for the flights and logs. We're going to add index permissions here. Kibana sample data flights. And we're going to add permissions. Don't forget to add permissions. Stuff goes very wrong. Okay? And let us do that also for the logs. And we're going to add index permissions for Kibana sample data logs. All right. And we're going to add permissions to access those indices. Notice, by the way, that these are permissions action groups. The action groups we actually define in the action groups tab. These are predefined The indices all just lets me do read and write to that index. Okay. So we now have these roles. But none of our users don't actually have these roles yet, right? We've just created the roles. Nobody actually gets those roles. So to do that, we map that role onto a particular user with a role mapping. Here, I'm going to add a role mapping that takes let's say, ecom user, and I'm going to add a role. Oh, I got this. This is what I want, sorry. Ecom role onto the ecom user. I don't need any backend roles. Oh. Okay. So we see here we have the ecom role mapped onto the ecom user. I'm going to do the same thing for the flights role onto the flights user. And then I'm going to actually map the logs role onto both of them. Not backend. Ecom flights user. Okay. Okay, so now we have our ecom role mapped on our ecom user, our flights role mapped on our flights user, and our logs role mapped on both. So now, if I log out, and I log in as my ecom user, and I put the password in. So now we can actually go, and let's look at our Discover panel. So let's see some of the data that we have in there. Actually, I did not put the data in there yet. Let me quick jump back into the admin user. Sorry about that. No, yes. All right. Let's try sample data. We're going to add this. We're going to add this. We're going to add this. So these are our three data sources. We have sample e-commerce orders, sample flight, sample web logs. We'll see some visualizations of these so you can get a better feel for what's actually in them. All right. We now actually have data in there. That's good. So let's go back and be our ecom user. And let me quick go. Oh, you know what? It's a demo, gang. We have to do one more thing. In order to be able to use Kibana, there's a Kibana user role that you need to have. Otherwise, you don't get to use Kibana. So we need to map our Kibana user role onto our two users. This is Kibana user. And let us add users, ecom user. And let's add flights user. Okay. Now we have Kibana user for those guys. That should work a little bit better. Okay. Let's explore on our own. All right. So when you use Kibana, you need to tell Kibana the structure of your indexes and where it can find time information. That's called an index pattern. We haven't gone deep into sort of how you use Elasticsearch much, but an index pattern tells Kibana, hey, here's a source of data that you can look at. So before we can do anything, we have to define that. Now you'll see I have access to logs, but why don't I have access to e-commerce data? If you know, shout it. Thank you. Let's go back and let's go over here. Was it in the mapping or in the role? Okay. Ecom role. Index. Oh, yeah. Thank you. Fumble fingers. Yes, okay. So let's go back. All right. Let's explore. Let's go over here. Yay. Okay. So let's look at our e-commerce data. I tell it the index and I tell it the timestamp. I'm going to use order date as the timestamp. Let's create that guy. Okay, you can see Kibana actually goes in and it finds all of the fields that are in my documents. I have this Discover pane over here that lets me look at, sorry, I'll do this slower. So this Discover pane lets me look at some subset of my data. Everything you do in Kibana is scoped to a particular time window. Not everything, but most of it. In this case, our time window is the last 15 minutes. Now we're using sample data, so actually the sample data pretty much falls outside of the last 15 minutes. We can adjust that easily by just setting it to today. And if we do that, then you can see we have a ton of data across today. And the kind of things that we have in here, we have a category for the sale, we have the currency, customer's name, customer information, location in terms of GeoIP, manufacturers, the products that were purchased, the total price and the tax-full total price. So this is the data that we're imagining is generated by an e-commerce front end. This is the data that we're going to use to search and to visualize. But for now, what we did is we created a role, we assigned it to our user, and our user has access to the indexes that are covered by that role, right? We're going to do visualizations, I promise. They'll be good eye candy. So let's talk about Kibana. Now, when you use open source Elasticsearch Kibana, there is a single Kibana repository. All of the visualizations and dashboards that you create in Kibana are stored in that single repository, which is actually an index in Elasticsearch. That means that anybody who has access to Kibana has access to all of those visualizations. And it's very common for multiple teams to be putting data in the same Elasticsearch cluster. You want to be able to have a different set of visualizations for Kibana for Team A and Kibana for Team B. Open Distro for Elasticsearch Security lets you set this up so that the Kibana experience for Group A has a set of dashboards and visualizations that is particular to Group A, and same thing for Group B. And this is provided through Kibana tenants, which are both Open Distro Security constructs and apply to users. So we're going to look at how to set up tenancy to support multiple different visualizations that are particular to individual users, and then some that are common across all of the users. And the way this is going to work is the ecom user will have an ecom tenant. When the ecom user creates visualizations, they're able to go in and put those into their tenant only, and only their tenant can see that. That tenant can be shared across multiple users if you want. Also, the flights user will have their own Kibana tenant. And then there are several tenants that are, well, there's a tenant that is global across all of everybody. Okay, so let's set that up. So we'll come back over here. Nope, got to turn off my presentation. Okay, we're going to come back and go into the admin user. And I'm going to go to the tenants tab. So this shows all of the tenants that are in the system. Nope, I went to the wrong place. Darn it. I always get that one wrong. Here is where we want to go, to this. Okay, these are all of the tenants that are in the system. So within the security plugin is where you set up tenants. We're going to have an ecom tenant. Oh, and that is a description, not a name. You know you lose 50 IQ points as soon as you stand up in front of people, right? And we're going to have a flights tenant. And we don't need a description, really. OK, so now we have created tenants. And actually, in the back end, the security plugin has made multiple indexes that are Kibana indexes, one each for each of the tenants that I'm creating here. OK, so now I have these tenants. I can go and I can say which roles have access to which of these tenants, right? So if I go to my security dashboard, and I'm going to look at my roles, and I am going to pick the ecom role, and here I have my tenant permissions. So in my role, I can say this role has access to this tenant, right? So here, I'm going to add a tenant permissions, and I'm going to add a tenant pattern. This is going to be ecom tenant. This one is ecom role, good. And I'm going to add permissions. Now I can make this user either read-only or read-write or write-only if I wanted to, but we're going to give it both read and write. Read obviously can only read the data. Write, you can create visualizations, dashboards, all that stuff. All right. So that is our ecom role. You'll see we've added our ecom tenant here. We're going to do the same for our flights. Tenant permissions. Flights tenant. And we're going to add permissions. OK. All right, so now our tenants are set up. So theoretically, I can go and create visualizations and dashboards from my ecom user that my flights user can't access. So let's show that. So let's be an ecom user. And I'm going to go here. So this is the tenant selection. As I am an ecom user, logged in ecom user, I get to choose which tenant I'm creating my visualizations and dashboards with. So I have access via the role to the global tenant, which everybody can see. I have a private tenant, which is specific to this user. And then I also have the ecom tenant, which I just set up, right? So I'm going to select the ecom tenant. Now, everything I do in Kibana is now under that tenant, OK? So I'm going to go and create. We need an index pattern. So e-commerce. I don't know why it's making me do this again. And we're going to go order date. OK. So let's create a visualization. We haven't talked much, really at all, about Kibana visualizations. So Kibana has a rich set of visualizations that you can use. And what they do is they take the data that's in your JSON, and they aggregate that data and allow you to slice and dice, somewhat similar to an OLAP cube if you kind of understand that concept. So I can create buckets, I can create sub-buckets, and create numeric operations on the contents of those buckets to provide the backdrop for what is going to be visualization. So let's look at an area chart. OK, so again, we're scoped to the last 15 minutes, not a lot of data there. Let's refresh that. Oh, what have I done now? Let's do this. So the first thing I'm going to do, and especially for time series data, is I'm going to put a date bucketing on the x-axis so that I bucket stuff across time. Hopefully that is going to give me more than 1 point. And there we go. OK, good. So what I've done here now, we have a visualization that shows me per 30 minutes how many, the count of items that are in that time frame. Right? So this is literally just a count of the log lines that went into this. There's not anything yet. So let's actually sub-bucket that. And we're going to go into, we're going to look at the terms that are in the category field. That is disruptive. Okay, so, but you guys probably can't hear because you got your earphones on. So what we're going to do now is we're going to take this bucketing and we're going to sub-bucket by the category of the purchase that represents. So now what I have is, you can see here, I have green as women's clothing, blue as women's accessories, et cetera, right? So I simply bucket out across the categories within the time window, right? So that's useful, and what we can do here is we can save this, and let's call this category sales. Okay, so all of this, again, happening within the e-commerce user, right? Now let's do a global one. So let's go over and, nope, not log out, sorry. So we're going to go and create a visualization. Actually, we need to create the index pattern first. Let's create the logs index pattern. So again, we're just telling Kibana what is in the logs index, not at, nope, yep, there. Okay. So now we have both a logs and e-commerce index pattern. So we can come over here, create a new visualization. In this case, what we're going to do is a stacked bar chart, vertical bar. And we're going to do that with the logs data. Right? So when I create visualizations, they're scoped to particular index patterns. So I'm going to do the logs data. And here again, I'm on the x-axis. I'm going to bucket by time. So I do that with a date histogram. And I make my window bigger. Okay, so again, what we're looking at here is a histogram, which is just a bucket of counts for what's in there. Now, actually, what's kind of useful is to sub-bucket that by what the response code is, right? So these are all HTTP requests. They all carry a response code with them. We'd like to see the errors, have those jump out. So we can do that easily by doing terms. Terms just says, look at the values of the field and make buckets for each of the terms in the bucket, right? So in this case, we're going to look at response. Where is it? So the response is the HTTP status code that came back for that particular log line. So I bucket that out. And you can see mostly we have 200s. We have some 503s. We have some 404s. Obviously, I'd want to dig into the 503s. I realized I made a mistake. We should first switch to the global user, global tenant. So I did all that within the e-commerce tenant. We actually want to make this a global one that everybody can look at. Okay, so we're going to switch tenants to the global tenant. Everybody has access to that one. Then we're going to do that visualization again really quickly. So let's create a visualization, and let's go vertical bar. And crud, I have my permissions wrong. That's awesome. Or maybe I haven't created the index pattern yet. Nope, I didn't. Let's do this. Sorry to mumble at you. Okay, no. Okay. Then we're going to come over in the visualizations, create a visualization, vertical bar, logs, x-axis. You can maybe get a sense of how easy it is to kind of dig into your data. This is why Elasticsearch is so tremendously popular. Okay. And make my window bigger. Okay. Same graph, different tenant. Okay, now let's save it. All right, let's confirm the save. Okay, that was all in the ecom user under the ecom and the global tenant. Let's log in as the flights user. And we're going to go and select, let's select the global tenant. That's who we have. If I go look at my visualizations, you can see here, this is the global responses that the ecom user created, but it does not have access to the total sales graph or the category graph that the ecom user created, right? So I can just click this, and if I make my window bigger, I'll have the same graph, right? So again, differential access, different Kibana experiences. This applies to visualizations. It applies to dashboards. Like all of the content that I'm creating, all of the analysis tools that I'm using are specific to the tenant that I'm using to log in, okay? All right. Okay. Now, as I mentioned, Security Plugin also provides you with auditing details about things that go wrong on your cluster. The Security Plugin puts a document into your security audit index when, for instance, in this case, you can see, I don't know if you can see, it's a failed login. There are a number of different things, bad permissions, failed logins, a bunch of stuff like that. So you can track all of that stuff within Elasticsearch and make sure that people are using your Elasticsearch cluster correctly. So one thing that's really actually useful, and one thing you probably want to do, is actually get alerted on a bunch of failed logins at some threshold, right? You want to have an alert when somebody starts hammering you with bad logins or other security issues that you might have. So we're just going to touch quickly on the alerting plugin. The alerting plugin allows you to monitor what's going on in your logs, define actions that you should take, well, define triggers at which the cluster should take an action, and then actions that it takes. Fundamentally, the actions, well, let's start with the monitor. The monitor is essentially a query, an Elasticsearch query that you write that generates a value. Something like the count of 503 errors, or the count of failed logins, et cetera. The monitor is just producing a value at a particular time rate. The trigger then is a threshold for that value. So if the monitor produced number of failed logins greater than 100, this trigger becomes active. And when the trigger is active, it starts doing the actions that you define for that. The actions in this case are basically deliver a message to a destination. The destinations available, we have Slack, Chime, and custom webhook. You can actually send it out over to any webhook you like. So let's look at setting up some alerts. And I'm going to quick jump out and become the admin user again. On our security data. Okay, here we go. This is our alerting console, and you're not seeing that. There we go. This is our alerting console. Again, we first create, actually it's easier if you create a destination first. So we're going to add a destination here. The name is going to be Slack. And the type, again, Chime, Slack, or custom webhook. We're going to use Slack. And I actually have the webhook URL. So when you set up Slack, within Slack, you can generate a webhook URL where you can forward messages and they go into your Slack channel. So that's what this is. I have my webhook URL here. Nope. And I'm going to create that. Okay, so that's a destination. In other words, that's a sink for the data that my action is going to produce. Then I'm going to go and set up a monitor. And in this case, we're going to call it, let's see, security monitor. Probably not a good name, but. And with my monitor, I can set a frequency that monitor should run. So that monitor is a query. It's running on my log data that's in my Elasticsearch cluster. I'm going to go by interval here every minute. I also can use a cron expression to set up how often the monitor runs. And I'm going to define it. So I can either define it visually, or I can just put an Elasticsearch query right in there. In this case, we're going to do it visually. And I'm going to pick my index. And we're going to go the security auditing index. Now, this does take a pattern as well. So I could wildcard this so that security audit log, which is time-stamped, it'll apply to all of them. The time field here is the timestamp. So when the count of over all the documents for the last hour of the audit category, you may not have caught that. Audit category is where that, that message comes that is what was the failure is, and I think it's failed login. Yeah, no data. What did I do wrong? Maybe I don't have any failed logins. Did I do what? Which one? No, I don't think it's. Should be right. It may be just that we don't have. Oh, there is data. Okay, there's just no. Okay, I spelled it wrong, but here, let's do this. We're just going to go. Let's just fail some logins so we have some actual good data. Okay. Then we'll log in as admin again. And we'll go back to the alert. And we're setting up a monitor. It's okay, security. And we're going to go blah, 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 blah. And then we're going to use the audit log. Timestamp. Yep. Now we actually have some data there you can see on the right. So audit category, failed login. Okay, good. All right, so this is previewing for me what I'm going to see. So let's create that monitor. And then we get to create a trigger. So we're going to trigger on failed logins. And we get a threshold. In this case, let's just set it to 1. Anybody fails to log in, we want to get notified about that. You can see we have this trigger line here that's going to say, visually, when is this going to become active? And let's take an action. Failed login is going to go to Slack. And the message subject is someone failed login. You'll see here the message is a mustache script. I can actually pull stuff from the monitor query. I can pull data about whatever's in the audit log itself. In this case, I just have a trigger name and the severity and the start and the end. This is a preview of the message that I'm going to get. Let's create that trigger. And at the moment, we have no alerts because we need to refresh. But you can see here where the trigger itself has actually become active. So if I go over to Slack, and I maybe have to let's see. You can see this one should be right. 22:43. Anybody know what time it is in UTC right now? Well, anyway, this is what I would get in my Slack channel. All right. So a couple of things to say, a couple of things more to say. Open Distro for Elasticsearch, pretty easy to get started. Visit our website, download Elasticsearch Kibana packages, load and query your data. Again, Docker, RPM, Debian installs. And you can also deploy with CloudFormation. I actually wrote a stack. There's a couple of labs that are going to use this stack if you want to deploy it onto AWS. And here's our project website, opendistro.github.io for Elasticsearch. That's the main website. Source code is all in GitHub. And the last thing I'll give is a couple of takeaways. Open Distro for Elasticsearch, fully Apache 2.0 licensed, distribution of Elasticsearch open source, along with additional plugins that give you security, SQL, alerting, and performance monitoring. Security gives you fine-grained access control the ability to div multi-tenant Kibana where Group A and Group B are distinct and their access patterns are distinct as well. And that is Open Distro Security. And thank you very much for coming out.